Hi, hello everyone. Welcome back to my channel. So in last class we are studying the this cantilever beam. Now we are going to study the simply supported beams. For that also we want to draw the shear force and bending moment diagram, how it will be there. So simply supported means we want to get an idea of a construction of a house, how they constructed. So two supporters, one in between there is a beam like a roof of a house. So in that beam carries a load, so it will be bear the some load. So how, at what, at where the load act on the beam, and how the supporters will be support that load. So likewise we want to consider this here also. So here also there is a two supports. See the diagram for the cantilever beam and the simply supported beam, there is a vary. So see varies, in that we want to consider one rigid body. So we want to fix it this one bar. So here not like that. So supporters, so these, first of all we want to find these supporters considering as a reactions A and B. Ra plus Rb is equals to total load, how much it can bear the load. So that is, it can bearing 2.5 plus 3, that is the total load of this bar of this beam. So Ra plus Rb is equals to 2.5 plus 3, that equals to 5.5 kilonewtons of load it can bear the reactions or supports. So now after that, finding the Ra plus Rb, this is a general equation. Then we want to take a moment, that means we want to fix one position. So by fixing at point A, now taking moments about fixing point A. So now log this one and coming from the right hand to this fixed position, at what distance. See now Ra is fixed. Next it coming towards the Ra, that means Rb, this from the end to the, we want to come Rb into at a distance what, 1.2 minus, next this load C, point C, 3 kilonewtons load coming towards the portion A. So at a distance is 0.8, that means see Ra into 1.2 minus 3 into 0.8 meter distance is A, for A to C is 0.8, that distance. Next minus again another load also in between after the A, so that is D, 2.5 kilonewtons into 0.4, that equals to 0, because it should be equilibrium. So for the equilibrium equation is that becomes equal to 0. All the force into distance towards the A is equals to 0. And next here see Rb into 1.2, these values. Here we don't know Rb value. For finding of Rb value, we want to write like this equation by fixing one is and coming from the other end. So here only is unknown is Rb. So we want to find the Rb value. How means, if in the place of Rb value we want to substitute the x, and remaining all we want to substitute in Casio, then we get a Rb value as a 2.83, or else we can go for this equation also. Here we know Rb into 1.3, so we want to take it the outside because unknown parameter we are here. So that is equals to, then substitute this value in Casio up to 0.4, then you get a 2.4 plus 1, or else directly 3.4. If you substitute in Casio this value, then you can get a 3.4. And next Rb into 1.2 is equal to 3.4 now. And then next we want to unknown is Rb. Rb is equals to 3.4 by 1 by 2. 1 by 2 becomes 1.2 becomes a denominator, and it becomes a divider. 3.4 by 1 by 2, that equals to 2.83 kilonewtons. This is a reaction. After finding out this B, we got at the Rb value, and unknown is Ra value. Both supports we want to find. So general equation is Ra plus Rb is equals to 5.5 kilonewtons. So here we know Rb value, and we want to find the Ra value easily here. So by substituting the Rb value, see here Ra plus Rb value is what, 2.83. So 2.83 is equals to 5.5. No, in the place of Ra we want to substitute x in Casio. See, wait, I will show. See here how to do a calculation in Casio. So here in top one also there is a same procedure. Here Ra is unknown. For that alpha into this x, and then plus 2.83 and is equals to alpha solve. This we want to press. is equals to 5.5, and then shift solve, then is equals to, then you get a 2.67 value. See here, 2.67 value. So likewise you want to consider same for this one also. Next, after getting all the RA RB value right here, and then likewise only same as a cantilever, that means cantilever beam only. Here also we want to consider the portions. So before that we want to find the reactions, how it will be there. So after finding the reactions, we want to take the consider this section, that means portion CB in between section XX, and likewise only here also in what is the right hand side, that force only we want to consider the shear force. And next bending moment is force into distance. Same procedure, same method only, but here except we are finding the reactions only. So see the shear force at point B. See at point B what is, so only we have RB value is 2.83. So now shear force is, see already in whenever the load going to downward to upward side, then it becomes a negative. It coming from top to bottom means that becomes a positive. So here the load is acting how means moving towards upside. So for that shear force at point B is minus 2.83. And next bending moment is what, at point starting point to this one there is no distance. For that force into distance is 0, distance 0. So then becomes a 0. Force is 2.83 into 0 is 0 only value. So that is a 0 kilonewton. So next shear force at point C. At point C what shear force? So two loads, that means minus 2.83 plus 3 at point C. And now we are not considering in between. So now at point C, no, 2.83 plus 3 we will write here. See minus 2.83 plus 3. Why? Because minus means we are studied. That becomes 0.17. Bending moment is what here? See at for this portion distance is what, at from the B. So force is 3. That means 2.83 into 0.4 is the distance towards the portion C. So then becomes as a 1.13 kilonewton meter. So next shear force at point D. At point D we are considering now. So minus 2.83 plus 3 plus 2.5. Then we get a plus 2.67 kilonewtons. Next likewise bending moment. So plus 2.83. See here. This towards the portion D now. Plus 2.83 into distance is what for the D. For we from this B to D is 0.8 only. So from A to C is 0.8. From B to D is 0.8. So 0.8 minus 3 into 0.4. This value is 0.4. For this value also 0.4. 0.4 plus 0.4, 0.8. So that one. See here. At portion D for the portion BD. Next. At point A, shear force at point A is what? 0 newtons. Why? Because starting and ending are 0 in the simply supported beams. Okay na? Then bending moment also becomes 0. Force is 0 means distance is there. Here we have distance is 1.2 from the point B to A. But load is only 0. 0 into something 0. So this is the calculation. Now how to draw the required values to the diagram. So now see here we get a negative sign also. In cantilever beam we are not getting any negative values. So here we are getting negative values and positive values. For that how we want to draw? So shear force and bending moment diagram. So we got a value is minus 2.83 here. So for that it comes downward, and in between CB there is no any load, then becomes a constant line. And again the value is 0.17, move towards the positive side at a certain height. And then in between DC there is no load, moving as a constant. And then again 2.67 moves upwards and constant. So this is a shear force diagram. Likewise bending moment diagram. At point B there is no distance, no. For that at point B is 0 and moves towards the point C. Here we got a plus 1.13 value. It is above only, not below. Below means negative, above means positive. So it plus 1.13. And next at point D, again the value reduced, plus 1.064 plus 1.13 is bigger than the 1.06, so it comes downwards. And next at point A is also 0, because shear force at point A and bending moment at point A is 0 0, because force into distance is force is only 0. At starting and ending is 0 in the simply supported beams. So this is the way of solving a shear force and bending moment diagram in simply supported beams. So thank you for watching this video. Please subscribe my channel. If you have any queries, ask in comment section. I will clarify in comment section. So thank you and all.